Let's start by solving the first question. So in the diagram, O is the center of the circle and the radius is 18. QR is tangent to the circle at P and line segment OQ intersects the circle at S. So we need to determine the size of the length of SQ. So we can see that OPQ is a right angle triangle, so we can use the Pythagorean Theorem. OP squared plus PQ squared is equal to OQ squared. So we have 18 squared plus 24 squared is equal to OQ squared. So we can do the calculations. So OQ is equal to 30. So this is equal to 30. And because we know that in a circle, each of the radius has the same, like all the radius lengths are equal. So OS is equal to 18. Therefore, we can find that SQ is equal to 13 minus 18 and 12. So that's it for question A. Let's move on to question B. So firstly, there is an inscribed circle in the quadrilateral ABCD. So it is tangent to all sides of the circle. So notice that we have a mathematical proof of geometry you should know, which is just like the tangent is perpendicular to the radius. Well, this proof means that if I have a circle with a center of O, and then I can have a line, let's say it's PTQ. If PQ is the tangent to the circle at T, then we should know that PQ is perpendicular to OT. So this is the proof we should know. Now let's continue reading the question. So we know that they are tangents, so these are all perpendicular. Nice. Next we can find that the radius of the circle is 12, so all these are equal to 12. OB is equal to 15. OB, so we can extend OB and it will be equal to 15. OC is 20. So what is the perimeter of quadrilateral ABCD? So let's write the proof together. So let's go. So firstly, we know that because okay, nice. We can know that proof. Firstly, we know that we actually know that DH and DG are equal to 12, but we need to write a proof for that before we can use it. So proof that OH DG is a square. We know that OH is equal to OG equal to 12, which is the radian. And we also know that we also know that angle OHD is equal to angle HDG is equal to angle DGO is equal to 90. So we know that OHDG is a rectangle. Okay, actually this one should go later. Okay, so then we know that this is a rectangle. So then we can say that because OH is equal to OG equal to 12, right? Because they are the radii. So we can prove that OHDG is a square. And similarly, we can prove that OHAE is a square. I will not write the proof to save time. So now we have proof that they are a square, so we can use that HE and AE and DH and DG are equal to 12. Thus, we can write that OH is equal to DH is equal to DG is equal to 12, property of square. And we can write that OH is equal to HA equal to A equal to 12, which is another property of square. Now we have found half of the sides of the quadrilateral. Let's find the other sides, which are not squares, but we can use the Pythagorean theorem. Let's continue solving the question. So after we found like half of the edges, now let's find the remaining edges such as GC and OF. So we can use the Pythagorean theorem because this is a right triangle. So by the Pythagorean theorem, we know that OG, let's write the whole proof. Because OGC is equal to 90 degrees, we know that OG squared plus GC squared is equal to OC squared. OG is equal to 12 because it is the radius. So 12 squared plus GC squared is equal to 20 squared. 20 squared is, OC is 20 because it is given. So we can solve for this one. So GC is equal to 16. Oops. 16. So by symmetry, since OF is also equal to 12, OF is equal to 12, OC is equal to 20, angle OFC is also equal to 90, so CF is also equal to 16. So that's this. And then now we can find EB and BF because OEB is equal to 90 degrees. So OB squared is equal to OE squared plus EB squared, Pythagorean theorem. OB is 15 squared is equal to 12 squared plus EB squared. So then we can find that EB is equal to 9. So to save time, we can find BF and EB similarly. So let's find the perimeter. So the perimeter is just like all these sides added up. We have 1, 2, 3, 4, 12 times 4 plus 9 plus times 2 plus 16 times 2. That's 48 plus 18 plus 38. So the final answer is 98. Now let's solve question C together. So we have circles A and C inscribed in the squares as shown. The area of the large square is 289 and the area of the smaller square is 49. So the length of one edge of the larger square is just square root of 289, which is equal to 17. And the edge of the smaller square is equal to 7. So I'll just write these proofs in case we need to write them for the contest, but for now I can erase them so we don't run out of space. So because we know that each edge of the square has a has a length of 17. So the diameter of the circle this circle is 17, so that the radius is equal to 8.5. Similarly, over here, the radius is equal to 3.5. So we can find OC by using the Pythagoras Theorem. If we have this length, so we can find this length. So because we know that this length is 3.5 and this length is 8.5, so we should know that this length will also be 3.5, and this length will be the difference between the two lengths, so this is going to be 5. So similarly, over here we have 8.5 because this is 8.5, and this is a square because it's 1/4 of the whole square, and this is all 3.5. So in total, this length will be 8.5 plus 3.5, which is equal to 12. So finally, we can just solve for OC. 5 squared plus 12 squared is equal to OC squared by the Pyth theorem. OC is equal to plus or minus 13, or we can just write it simpler, 13 or minus 13, which is rejected because OC is larger than 0. So the final answer is OC is equal to 13.